Welcome. Today we're going to take a look at how we can do math with Java in a variety of different ways. A lot of things we have to do, especially in computer science, are based on the idea of solving math problems, and in Java there's no exception to that. So we have numeric data types we have to make sure we understand. We have to work with arithmetic, trigonometry, the Java math library, and how to deal with really big numbers, especially when doing scientific problems. So the Java numeric types, we have int and double are two numeric types that we really use. There's also long, short, float, but we don't worry about them. So an int is an integer or counting numbers. The range is about plus or minus 2 billion and change. And overflow is a thing. We can go too big or too small and wrap around to the other side. So it's kind of problematic. We also have double, and this is where the range of the real numbers, if we're talking math land, and the range is negative 2 times 10 to the 349 to 2 times 10 to the 304th. We've got a really wide range of values right here, because 10 to the 304th is redonkulously huge, I know. There is no overflow. If I go to 10 to the 304th plus 1, it's not going to go there, it's going to go to infinity. If I go if I go to negative 10 to the 349th, I'm going to go to negative infinity. There's no overflow. I don't go back over to the wraparound on the other side. We have special values of the negative infinity and positive infinity I just said, but we also have the really cool power of not a number. And we can take a look at that in our other videos when we're demoing how to actually run with this inside code. Now, PEMMDAS is something you probably learned back in the day, and so PEMMDAS is, if you notice, has an extra m inside here. So parens are always first and group statements only. There's no multiplication. We're talking about parentheses inside Java land. Exponents are handled with the math.pow. There's no special operator. You can't use the caret symbol or anything like that. Multiplication is done with the asterisk operator. Modulo, the second m, is the percent sign operator. You do your long division, you ignore the answer, and all you keep is the remainder. And guess what? It even works on decimal values. I know, it's crazy, but hey, it's all good. Division is done with the divide operator, and the data type matters. So make sure anytime you're doing division, you're specifying if you're doing int division or double division, because it really, really does matter how you handle that. Addition, guess what? We use the plus sign, and subtraction, we use the minus sign. I know, crazy stuff, but we're good to go. We want to compare numeric values. If we're working with an int, we compare our equality with equals equals or inequality with not equals. Hey, that works great. We don't use a single equal sign. Remember, the single equal sign always means shove it in from the right into the left. However, when we're talking about double land, we've got a totally different thing. Do not use the equals equals operator when we're talking about doubles. Instead, if you want to compare equality or compare double values, you subtract the two doubles and compare them against some predetermined close enough amount, aka 0.001 or something like that, and math.abs makes that very easy. So do not use equals equals when you're talking about doubles at all. Make sure you keep that in mind as you go and look at your actual logic for trying to compare numeric values. Casting is kind of a big deal. So casting is how I can change information from one type to another. And so when you cast values from double to int, it requires an explicit cast as the information contained in the double has nowhere to go. So you have to oh, what am I doing with this? Well, I'm going to turn it to an int. So I know I'm losing that information, or when I'm casting up from an int to a double, I know, oh, I'm gaining this decimal point. So casting up to a double should be done before the mathematical operation, so information is not lost. And so we see right here, we have double demo is equal to parens double of 7 divided by 4. And it goes on the first value it sees. So in this case, the double is attached to the 7, not to the product of 7 divided by 4. When I'm casting down to it, however, it should be done after the operation so I can keep the extra information. So I have int other demo equals parens int, and then I have the result of math.random times 100. So I'm going to do the math.random times 100 to get that value with that and then turn that into an integer, because that way I can actually retain the information that I need when I'm casting down to an int from a double value. So that's a really important thing you want to keep track of when you're casting information, what you're doing to keep the information maintained as you actually work with that. We often, for some reason, in dealing with numbers, we need to deal with random numbers all the time. And so math.random is the default way to get random numbers in Java. It returns a double value in the range of 0 to 1. So you're using that math notation right there with the square bracket meaning inclusive and the parens meaning exclusive. So aka it can include 0, but it won't include 1. So it's a double range of values from 0 up to, but not including 1. I use it most often by multiplying by some scalar and then casting that result back down to an int from getting a random number. You can also shift that range up and down the number line by adding or subtracting after the multiplication event. And you can use dot size or dot length as a scalar when you're working with a data structure for getting a valid index inside that structure. So we have int random value equals parens int, and then we have the cast of the value of math.random times the scalar value, and then plus the shift. And remember, the shift can go up, it goes up the number line. If it's a negative value, it goes down the number line. So it's a great way we can do some good stuff with using math.random. There are some must-know math methods. So into the math class, we have a lot of stuff we can work with. Math.abs, the absolute value, it's absolutely beautiful, I know. And remember, you make a V shape with your hands right here. Oh, V, there's the V graph right there, math.abs. I know, cheesy joke, but it's great. Math.max and math.min are wonderful for calculating values. They're overloaded for both ints and doubles, so you can use any type of data with that. It returns the bigger or the smaller of the two parameters, and it's very nestable. So if you want to calculate a whole bunch of things, nest those math.maxes together, and oh, I can get all the maxes together on that sequence. Good stuff. We can also use math.pow, that's when we do exponents. It handles positive and negative and fractional, aka root values. And so all you have to do is pass those two parameters in for that, and you can have a great little example with that. Math.squirt, take out the vowels, it's square root, and that's what we have with that. So again, math.squirt quite often. Trig functions. You use trig functions all the time in your math class during high school and in college as well, but we also have to use trig inside Java as well. And these use radians by default, so remember that you have to keep that unit circle in mind, and they all take and return double values, and one of the few useful constants in the math thing is math.pi. I know, weird, because constants aren't that helpful. So we have standard of sine, cos, and tan. And we have the inverse of arc sine, arc cosine, arc tangent, and atan 2. Atan 2 is really helpful when you're talking about calculating some other information. Take a look at that when you're looking at how to calculate trajectories, because oh my gosh, it saves you so much time. And notice on atan 2, the y is the parameter. Yeah. Rounding and bounds. So we have round, floor, and ceil. They return values based on the fractional part of the double value. So they return a long as the data type, so you have to make sure you downcast that appropriately so you can use it as an int if you're working with that. Math.round behaves the way you expect it to, just like you learned in elementary for learning fractional values. Math.floor always drops all fractional values, so it's just like casting it right down to an int. Math.ceil always goes up to the next whole value. So if it's 3.00000001, math.ceil is going to give 4 back as the value. So keep that in mind. There's a big difference between math.ceil and math.round. Logarithms are a common thing we have to do, especially when we're working with, say, for example, calculus or doing resulting analysis of information in computer science. And so if you want to write any code that's going to actually work with that, you're going to be using math.log and math.log10, obviously for the different types of logarithmic-based functions. Math.log is the natural log of the nearest parameter, and math.log10 is a base 10 logarithm, quelle surprise, because, again, math.log10 explicitly says that it's a base 10. I know, weird. Now, what if you're doing some ridiculously huge numbers? Now, there used to be a case study inside AP for the big int case study, but Java already has that tool built right into it with the big integer and the big decimal classes inside java.math.biginteger and java.math.bigdecimal. So you can do arbitrarily huge value calculations. Say, for example, you want to do some science-based problems where you have to actually have lots of specifications, more than simply just, say, for example, 16 digits precision that you get with a double value. Then this is where you're going to get that information on there. It is a little bit slower than int and double types, but you don't have an overflow problem like you have inside int, and you don't have a lack of precision, which is, oh my gosh, so important when you're actually doing real calculations. So if you want to do big number calculations, java.math.bigdecimal or java.math.biginteger can solve that for you. Great for science projects. There's some other methods in math. I didn't cover everything because you take out the Java Math API, you can learn all sorts of cool stuff. There's so much you can do with math inside Java. I hope this is a helpful introduction to the Java Math library. Have a great day. We'll see you next time. Cheers. Goodbye.